Hello, Mr. Kaladi here. Today we're starting a new chapter, Chapter 4, which is all about statistics. So everything we're doing in this chapter is actually taken from the data management course and is very different than what we've been doing so far. Statistics is a whole branch of mathematics. A lot of you, almost every one of you, will take a statistics course of some sort in university. And it's concerned with analyzing large quantities of data, usually with the intent of making large conclusions about a large population. So there's a lot of definitions. Before we even start the chapter, there's a lot of definitions to get to know. And so what I have is a long example that we're going to work on to get to know these definitions. So we're going to try to answer the question, do IB students at St. John Paul II work hard? Well, that's a big question. And so first of all, we need to gather some data. Like, how are we going to know whether students are working hard or not? Like if I had to interview every student, what information am I going to get from them? So some types of data that you can get are qualitative or quantitative. You probably know these words already. Qualitative is a quality, it's not numerical. Quantitative data has a number to it. And actually, quantitative data, there are two types. There's discrete and continuous. Discrete data is data that can be counted. So if I asked you, how many books are in your bag, you can have 1 book, 2 books, 3 books, or 4 books. You can't have 2.2 books. Whereas continuous is a measurement where there's no gaps. It can be any number. So if I asked you how tall you were, you could be anything from 172 to 173 to 172.2 centimeters. So that's the difference between the two there. So for our example, what data could I collect that would help me determine if students were working hard? So for example, let's talk about quantitative data. I could ask every student the number of minutes of homework. Number of minutes of homework per night. As an example, we're just brainstorming different ideas here. Well, I'm brainstorming, you guys aren't actually here. I could get your average, so your student average, right? That would be a way, maybe your average would show me how hard you're working. I could even be creative, right? The weight of your backpack, right? A hardworking student would have a very heavy backpack because they're carrying around so many books. Anyways, sometimes you have to get creative. Now, discrete data, that would be something that I'm counting, right? So discrete, can you think of anything that I could count that's discrete that would help me know if a student is working hard? Maybe the hours of sleep per night, where hours is an integer, like, right? You can have 1 hour, 2 hours, 3 hours, 4. So I'm not counting the in-between. Maybe you could do I could count the number of pens a student owns. Number of pens a student owns. Right? That's a weird one, but again, you might have to think of some interesting ways of analyzing things. If I count the number of pens, maybe a hardworking student would have a lot more pens. Okay, now qualitative data is a little bit harder for this example. How could I measure that a student is working hard? What quality could I look at? I was thinking of like student hair color. Maybe students who have more white hair, they're stressed out more, so they're working harder, right? That could be something. Maybe the red-haired students work harder, so we just have to, collect this data. So the point is, you can collect data to answer a question, and there's different types of data. So let's say I've decided I want to look at the number of minutes of homework a student does each night. Okay, so now I would go and ask every IB student, how many minutes do you work on homework each night? Now, unfortunately, it would be very difficult to ask every IB student, right? Like, there's a lot in the school. Imagine if I was doing a survey of people in Canada. You're not going to go and ask every person in Canada. It's really impractical. So there's a difference between the population, which is the whole group that you're surveying, and sample, which is a smaller select group that you survey that is a stand-in for the population. So in this case, the population is every IB student in the school. It's impractical to interview all of them, so instead I'm going to choose a sample, which is some IB students. So the big question is, Well, which students am I going to interview to figure out how many minutes of homework they did per night? Think about like some problems here. If I interview all grade 9 students only, well, grade 9s are lazy. They don't do work. They don't take it seriously. So I might then find that my numbers for amount of homework per night is really low. On the other hand, if I interview grade 12s who have so much work, blah, 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 then their numbers might be high, might be skewed high. I might interview all guys or all girls. That would really mess up my data, right? Maybe they do different amounts of homework. I could interview people who are on sports teams only, which could really affect my numbers. So when you choose your sample, you have to be really careful that you choose the sample so that you have reliable data and data that's representative of the whole population. So let's say we have 250 IB students at St. John Paul II in grades 9 to 12. Let's talk about some different ways I can sample them. That is, some different ways I can interview them to collect data. Oh, sorry, I just talked about sampling bias. So the whole problem if you don't sample correctly. So let's talk about some sampling ways to avoid sampling bias. Convenience sampling. So this is, as it sounds, conveniently, you select people to interview who are the most easily accessible. So this would be, if you're in grade 11 right now and you're doing a survey, you're going to survey the people that are in your class, the people that are in your chat group. So you might interview your friends. Or 10 students. Or 10 students in my cohort. Or in your cohort, sorry. The point is, convenience is great. It's very easy, but it might, again, if all your friends might be on a sports team, so you get very bad data because you don't do a lot of homework. Okay, so that's not the best. The next kind of sampling would be simple random sampling. This is where each person has a random chance of being selected. I have a picture here. This is where you literally just roll a dice or have a random number generator that randomly selects people from the group of 250 to create your sample. So one way of simple random sampling would be to draw 10 names out of a hat. That's random and is going to ensure a random sample. Or use a random number generator. Okay, the next type of sampling is systematic sampling. This is where you list the entire population, and then you start at a random point and you take every fifth student or every third student. So again, it ensures that there's no bias. You're always choosing randomly based on that number. So I'm just going to write out my example here. For us, we write a list of all IB students. So from a list of all IB students, select every 10th student. Okay. Then there is stratified sampling. So this is where you divide the population into smaller groups, or also called strata, and based on which all have the same characteristics. And then you choose a random sample from each strata, or each stratum would be one. So for example, what are some ways I can divide up these 250 students? I could divide them up into all guys and girls. I could divide them up into eye color. I could divide them up into, what I like is divide them up into grades. So divide IB students into 4 grades and select 10 from each grade. So that would give me a stratified sample. Quota sampling is very similar. I divide the population into smaller groups based on shared characteristics, and then I choose a random sample from each strata that is proportional to the size of the strata. So for example, if I have, if I divide you up based on eye color, well, there might be a lot more students with, green eyes. So I need to select more of those green-eyed students, where the blue-eyed students, there's very few of them, so I only select a smaller amount of a proportion of that group. So this is going to be hard to write, but I have like, so if I have 40% are grade 9, 30% are grade 10, etc., then my sample has, you know, what would be like 8 grade 9s and 6 grade 10s, etc. So hopefully that makes sense, but it's basically the same. It's just that there's a proportional representation from each group. Whew, okay, so remember the question is, how hard do IB students work? Well, I'm going to ask how many minutes of homework they do each night. I can't interview every IB student, so I'm going to choose a sample, whatever sample you like here, probably systematic or simple random sampling. And you're going to collect some data. So you're going to interview each student, ask them how many minutes I did hours. They work on homework each night. And so here's my data. One student said 4, 6, 2, 3, 5, 10, 6, 22. Whoa, 3, 3, 6. Okay, before we go any further, we should talk about outliers. These are extremely large or small values that may be considered to be removed from a data set. Outliers are numbers that, they're out there. We'll talk more about outliers, how we calculate them, but they seem to be very large or very small. And looking at this data, I can see 10 seems to be an outlier. That seems to be quite large. And 22, well, that seems to be quite large as well. So outliers can be removed if you can explain them. Now, this 10 here, well, it's a very big number. That would mean you have to get home from school at 3 o'clock and you would have to work until 1 a.m. and not stop for dinner. That's possible, right? Like, it's possible you have a student who's doing that. So this is possible. So it cannot be thrown out. '22, on the other hand, well, if you're going to school, if you're sleeping for anything more than a few hours, this is basically impossible. This must be an error. Maybe the student entered it wrong. Maybe they did it as a joke to try to mess up your project. Maybe they didn't understand the question. But either way, this is going to mess up your data, and it doesn't really belong. So this is impossible. We can't just remove data willy-nilly from our data, right? Like that's like, you know, kind of cheating. Like that's fixing the results of a study. But we can, you know, acknowledge that this was a result that we got, and that we're removing it from the data because it's an outlier. This is still an outlier, but we can't explain it away, so we have to treat it as a valid answer, or a valid piece of data. Okay, let's turn the page. So now that we have all this data, now, I mean, when I write it like this, it's not very useful. It doesn't tell me much. So the point of this chapter, this whole reason we're studying statistics, is so that we can present and summarize this data in a useful way. So the beginning of this chapter is univariate analysis. Univariate analysis is when we have only one variable, sort of like this question we've been looking at with the number of hours of homework. We're going to show you some ways you can present one data. You can use graphs. We're going to do that in section, what is this, 4.1, 4.3, 4.4. We're going to show you how to do that using the central value. For example, we're going to show you how to find the average of this data, which is a useful way of representing it. That's in section 4.2. Thirdly, we're going to show you how to measure the spread of the data, or the ranges of the data. This is another way of analyzing and presenting the data. So we're going to do that in section 4.5. So that's the first half of the chapter, univariate analysis. The second half of the chapter is bivariate analysis, which is where we look at where we compare two sets of data and the relationship between them. let's not get too ahead of ourselves, but that would be if I plotted on the x-axis the number of minutes, or what was it, hours of homework, and on the y-axis I plotted some other statistic. For example, your mark. So each student would have 2 points. So someone does a lot of homework, low mark, and I plotted it, and I would see the relationship with all these different points between the number of hours of homework and the mark. I would see that as you do more homework, your mark goes up. Hint, hint, hint. So this is all in section 4.6, 4.7, 4.8, 4.9. That's the second half of the chapter. So we'll get there. So there's a lot of definitions there. A lot of these terms will come up throughout the chapter, and there's something we should consider as we go, because the integrity of our statistics is really important. So here's some quick questions you can do where you just have to use some of these definitions. Now, let's just go to section 4.1. And section 4.1 will be the easiest section in your math career since grade 9. But basically, one way of presenting data, univariate data, is using graphs or a table. Now, if you're given discrete data, which again is when you have numbers that you can count, you would represent this with a frequency table and a bar chart. Have you ever made a bar chart or a bar graph? I bet you have in grade 5. Well, that's a way to present data. We taught you from a very young age. Now, if you have a lot of discrete data or continuous data, you're going to use a grouped frequency table. We'll see one below. And to represent this data with a histogram. What's the difference between a histogram and a bar chart? In a bar chart, the bars do not touch. In a histogram, the bars touch. Now, you've made bar charts before, right? If I were to figure out the hair color of everyone in the class, I could make a bar chart. You know, this many red-haired people, this many brown-haired people, and that would be something you've done a long time ago in grade 5. But let's start looking at this more difficult one. When I have lots of data, I use a group frequency table. So, for example, Mr. Colley wants to collect some statistics. He finished grading his calculus test. Here are all the percentages. Again, when I write all the data like this, it's not very useful, right? It's just meaningless numbers. So I'm going to present this in a group frequency table and then a histogram. So notice what type of data this is. And with IB, often we don't have in-between percentages. So these are just discrete numbers, right? You can't have 82.5 according to this data. But when I want to collect this data and present it, because it's lots of continuous data, I could use a group frequency table. What I'm going to do is sort all of these marks into different bins, 0 to 10, 10 to 20, 10 to 30, 20 to 30, et cetera, et cetera, et cetera. So let's figure out the frequency, or the number of data points that are in each of these bins. So to do this, I just go through one at a time. So 45, well it goes in my 40 to 50 tally. 74, 13, 38, 79, where are we, 68, 95, oh great work, 78, 64, 134. Now we should think about it. Is it possible? Pretty much impossible to get 134%. I mean, maybe if you got a bonus you get 102, but this seems like it must be an outlier. Must be an outlier that can be removed. Right? I don't think 100. I might have entered that mark wrong or made a mistake, so I should go back and check, but I'm going to throw out that data. Or maybe a student hacked into my mark book and changed something. Okay, this is 55, 59, 82, okay, 60, well that's 60, so it should be in this bin here, 75, 76, 62, 91, 88, 34, 77, 73, 61. Whew, okay, there are all the marks. So now I can find the tally, the number of students in each bin. Oh, did I make a mistake here? Oh, I put 13 in the wrong spot. It should be here, right? Oops. So there are 0 students in this bin, 1, 0 with 20 to 30, 2, 1, 2, 5, 1, 2, 3, 4, 5, 6, 7, 3, and 2. So again, like the student who has 13, they could be, again, I'll show you how to analyze outliers later, but this could be an outlier, but it's not an outlier I can throw out, right? This student has a very low mark. Maybe they were sick the whole chapter and then they got a low mark on calculus test. So they're still an outlier, probably, but I can't throw it out because I can't, there's no explanation. There's no reason why I can clearly remove it. So that's my group frequency table. So I've taken the statistics and I've represented them in a table. These numbers are not my statistics. They just help me understand that, oh, there are most students happen between 70 and 80, and give you an idea of how the data looks. It's more useful to use this table than to use this list of numbers. And more useful even than that is to make a histogram. Now a histogram is just a bar chart for numbers, basically. So I'm going to write on my x-axis, always when we're dealing with one statistic, because the statistic here is your calculus grade, along the x-axis I'm going to write the statistic itself, which is your test percentage. Your y-axis is just frequency. It's the number of times each measurement comes up, each bin comes up. Our frequencies go from 0 to 7, so I'll draw those in. 0, 1, 2, 3, 4, 5, 6, 7. And my percentages, okay, well I have 0, 10, 20, 30, 40, 50, 60, 70, 80, 90, 100. Okay, and now I can draw my bars for each of the bins. So from 0 to 10, there's 0. From 10 to 20, there's 1. So I'm going to draw that bar. So again, I told you this would be the easiest thing you've done in a long time in math class, but it is part of the IB curriculum. 20 to 30 is 0. 30 to 40 is 2. So then 30 to 40 goes up to 2. And then the next one goes up to 40 to 50 goes up to 1. Okay, then we have 2, 5, between 60 and 70, yeah. Then we have 7, and then we have 3 and 2. And now I can fill in the bars. Okay, there, nice and tidy. So this is my histogram. You note that because the data is continuous, or in this case it was discrete, but then we put it into continuous bins, the histogram, it's continuous, right? The bars do touch. And you have this, yeah, there we can see very visually now where most of the marks are concentrated, and we see where we have some students with higher and lower marks. We won't go too far into this, but we're going to return to the idea of a histogram because this characteristic shape of having most of the students in the middle, this is something that's going to come back in later chapters. So just kind of a preview to what's coming. But essentially, this whole chapter is about collecting data and then presenting it in a way that we can compare it to other groups. So the first lesson, which again is pretty straightforward, is using tables and making graphs. So please take a look at the homework, especially this homework up here with these definitions. But some of this is a little bit new. Like group frequency is new to you, so it is worth at least taking a quick look at the homework. Will be so it's the questions above, as well as page 257, number 1 to 2, and page 259, number 1 to 4. For that, you have no GDC. I just want you to sketch. Okay, good luck with that, and we will see you next time.